Oh, you're trying to SSH into Orac? Are you hacking Orac? That's not allowed. You have to delete this message. How dare you? Let that be an example to the rest of you folk. Could you zoom in on your terminal, please? Did that work? Oh, but it made this bigger, which is weird. Okay. Yeah. Hello? Okay, wonderful. I think you can all hear me. Okay. What were we doing before I so rudely left to get dinner? Which I'm still eating, by the way. Got a nice bento box from the Japanese place around the corner. They tried to upsell me miso soup and a salad for $5. Can't believe they would try that on me, of all people. Okay, so it was Range Trees and DP. Oh, that's right, DP and Range Trees. Should I give people more time to come in? I apparently only have 10 viewers at the moment. Well, maybe people just weren't interested in continuing the stream. That's also fine. Okay, I guess I'll just continue. What was I doing? Range Trees. Okay, I need to find that problem. Oh god. Okay, have you all looked at this problem, cannons, from the set? This is like the quintessential DP plus range tree problem. Have you all solved it? you didn't solve it with a seg tree? Interesting. Okay. Well, the problem is pretty simple. You're given a set of cannons. Each cannon can fire you up to some distance to the right. You would like to get from the very first cannon to the very last cannon. Well, get from the very first cannon, like, past the end of all the cannons. And the thing is that each cannon has like a certain value that you get added to your total excitingness if you use it, which might be negative. And each cannon has a certain different range that's able to fire you. And you'd like to maximize the total number of points that you get. So if you do this naively with a DP, your state is going to be which cannon that you're currently at, and your occurrence is just to pick one of the cannons to your right that you can reach and find the best one, the one that gives you the maximum score, and use that. The problem with that though is that it's kind of slow. Order n recurrence, order n states, so it's order n squared in total. But you can actually speed it up by throwing a range tree at it. So the idea is this: let dpi be the max score you can get if you start from cannon I. If you build a new array and the values of the array are dp 0, dp1, dp2, oh god, and so on, up to like, zoom in, sure. dpn is fine, dpn. Then if you happen to have all these values already and you want to calculate, say, I don't know, dp50, and from there the cannon can fire you, say, up to 5 spaces to the right, then the choices you have are from dp51, 52, 53, 54, and 55. You just need to find the max of all of those. So you can kind of see how that's a bit like a range max query on this array that I've kind of just written here. The problem is that you don't actually know the values of this array up front, because you need to, because calculate the DP value for a given number, you need the DP values for other numbers. So it's kind of like a catch-22. But the nice thing about DPs that makes these kinds of range tree solutions work is that you can usually order the states in such a way where things are nice. So in this particular case, dp of x only ever relies on values that are larger than it. So, you know, x from x plus 1 to x plus k for some k, depending on how far the cannon can shoot you. So what you kind of do is you build this array one element at a time, and you can do it backwards. So initially this array is like all zeros or whatever. These values don't really matter, and the last value is dp of n, which you can quite easily calculate because that's just your base case. And to calculate dp of n minus 1, that's just the max of blah 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 dp of n. Yeah. Now the thing, oh, is this really clear from the example? And once you've calculated dp of n minus 1, you can then just do a range tree update to update your array. So it's now like this. So this is like your max tree over this array. And so as you go, you kind of build up this array one at a time. So at like the ith iteration, you'll be at something like dp of n minus I to n minus I plus 1, and so on to dp of n. So you're kind of building this backwards by extending the suffix one element each time. So the thing about this though is that usually when you're doing something like this, your recurrence isn't quite as simple as max of a bunch of DP values. It's usually something more like DP of 50 equals max of, if I were to jump to DP of 51, then I would also get like the excitement value of Canon 51 as well. And similarly, DP 52 plus 52, and so on. So you aren't just looking for the maximum DP value of the ones that you can reach. You're trying to look for the maximum sum of the DP value plus this excitement value. Does that make sense? So this max tree that you're building isn't actually over the DP values precisely. Well, there's kind of two ways around this. The first way is to build the max tree over not just the DP values, but the DP values plus the excitement values. So excite n minus 1 plus excite n. So that way, your max tree actually gives you the max that you're looking for. The alternative way is to redefine your DP so that these like extra excitement values are inbuilt into the value of the DP. So instead of let DPI be the max score you can get from Canon I, you would let DPI be the max score you can get from Canon I, including the score of Canon I. So this is kind of, when you're doing DP problems, sometimes you have different options for what you can make the state to be. But sometimes some states work better than other states for thinking about problems, and also sometimes for implementing them as well. So even if you have a state that works, maybe it could still be worth investigating other states that are related, even if they're not necessarily any more optimal, because they might lead to a more obvious, they might be easier for you to get from that state to a more efficient solution. Yep. Any questions about that basic idea? Okay, if not, I'm gonna make the problem a little bit more complicated. So now the cost of using a Canon isn't just the cost of using a Canon isn't free. In order to jump from Canon I to I plus K, you lose K dollars. So now with this restriction, the solution isn't so obvious anymore. Does that make sense? The cost is just n every time. Oh, it is. Oh no. Okay, actually, some Canons are expensive and they cost an extra K dollars to use to jump K. Otherwise, the rest are cheap. So they're free to use. So that's like the new problem now. Thanks for pointing that out. So now when you're doing this problem, it's not as obvious how to optimize the DP anymore. But it's actually pretty simple. So let's take a look at two different values of the array. So you have an array, it's like a bunch of stuff, and then like there's like a DP X here and a DP x plus 1. And then there's like some other stuff. What the? What is happening? Am I being... what's the underlying task? Maximize x. Oh, that's a good point. So it's not that you lose K dollars, you lose K excitement points or whatever. And your goal is still to maximize the total excitement. So now with this variation of the problem, it's not so obvious what to do, but let's do a little experiment where we consider two dp values, dpx and dpx plus 1. So we know that if we're ever going to consider dpx and we're ever going to consider dpx plus 1, the cost of dpx is going to be like dpx for expensive cannons, So when we're considering expensive cannons, the cost of going to x is going to be dpx plus some distance, depending on how far away the cannon we're currently looking at is, how far away the current cannon we're looking at is. And for dpx plus 1, it's going to be that same distance plus 1, because it's one further than the previous one. So when you're looking at this distance is actually common across both of them. So the only time you would ever pick, oh sorry, not plus 1, this should be minus 1. Yeah, this is minus distance, and this is minus distance plus 1. My bad, I'm mixing up min and maxes. Yeah, so the only time that you would ever pick this one over this one is exactly if dpx plus 1, even with the extra minus 1 penalty, is greater than dpx. So it's kind of handicapped by 1 because it's one space further in the array. So what you can do is, instead of storing the values as they are, you can kind of add a handicap to each value based on its position in the array. So instead of storing dp, I don't know how to write this out, it's kind of hard to say. So instead of it being like dp0 and dp1, blah blah blah, dp n minus 1 and dpn, you actually do something more like, because this is the last element, it gets a massive penalty of n. This is the second last element, so it gets a massive penalty of n minus 1. And if you had like a dp n minus I in here somewhere, its penalty would be minus n minus I. Yeah, and this one will have a penalty of 1, and this first value will have a penalty of 0. So in this way, by adding these little offsets to each element, you have that, by adding these offsets to each elements, when you do the max query over a range, you can get the one that would be the maximum even after you take into account the additional cost for using the expensive cannons. But what about the case where dpx plus 1 is 2e9 and dpx is 2e9? Because it would be ideal to jump through both of them. I don't know what you mean by it would be ideal to jump through both of them. As in, an optimal solution would jump to cannon x, and then from x jump to x plus 1. In that case, the value of dp x shouldn't be 2e9, it should be 4e9, right? like if it's optimal to jump from x to x plus 1, then the value of dpx should have that accounted into it. Yeah. So these values are like, it's not that you should jump to this cannon and skip the next cannon. It's like you should jump to this cannon and then do the optimal thing from there. That's like what DP is defined to be at the top. Yeah, so once you've kind of added these offsets in, the last thing you have to be careful about is that the offset values are relative. So the cost of jumping from, say x, the cost of jumping to dpn minus 1, let's say, from an expensive cannon isn't necessarily n minus 1, because that only applies if you jumped from the very start, which is kind of where, like, we let dp0 kind of be like the base of our offsetting, and everything else is relative to that. So when you're actually calculating the cost, you actually have to remember to add back the relative offset to make it correct. So for example, if you're jumping from I to j, then you have to subtract the offset at I from dpj minus its offset. So it's kind of a small detail that you have to do. Does that make sense? So in total, the final solution is that you actually have two different range trees. They're both max trees. The difference is that one of them is the normal DP values that we talked about before, but the second one is the DP values minus the offsets that we just discussed. And so you have to maintain both of these as you loop through the DP values. Yeah, so that's a more advanced case of using like range trees for DP optimizations. This is a nice little trick, and it's especially useful for problems where the cost is proportional to some kind of distance or movement or amount of something used. And that's pretty common in informatics. Okay, cool. Any other questions about this cannons problem? Okay. If not, then I think move on to another problem. Okay, so the other problem I wanted to talk about was this one, Super Mario Universe. Has everyone seen this problem? I actually don't think this is one that is public now that I think about it, because it came from one of the more recent AIIOs. Is anyone who is on the stream and hasn't seen this problem? Okay. The problem is much easier to understand from the diagram, which is unfortunately missing from this statement. So to the whiteboard it is. What is it called? AWW. All right. Okay, so the story is that you're playing a nice game of Super Mario, and in Super Mario, pretty sure we got it in trial exam Capricorn. Oh, well, there you go. So it's that you have a bunch of these platforms. Each one has a distinct height. And the way that things work in this game, in this world, is that you start on one of these platforms. And each platform gives you some amount of value. So this is worth 6 if you touch it. This is worth like 123. This is worth 50, and so on. And when you're on a platform, you get the points, then you have to choose to either walk off the left and then fall down onto whatever platform is there. You can't move after you've fallen, so you fall straight down, or fall off on the right, in which case you land on a different platform. And the question is, if you do things optimally, what is the maximum score you can get before you fall back onto the ground? Oh, this one's unreachable. You can't get here. So does the problem make sense? So unsurprisingly for this problem, like, where is... n is up to 1e5. So everything is really big. Or am I lying? Yep, n is up to 100,000. Okay, so the first thing that you'll notice is that the pretty naive DP is you make your state the platform that you're on, and your choices at each state is either to walk off the left or walk on the right. So the recurrence is, so the DP is like order n. The state has like n different platforms you can be on, and there's order 1 different choices you can make at each state. The difficulty though is that you have to calculate which platform you actually fall onto, and that can be quite tricky. If you do that naively by looping through all the platforms, then it takes order n each time you fall to figure out where you actually fall. But with some pre-processing, we can do it a bit faster. And unsurprisingly, you can do it with some range trees. Now, the intended solution for this problem was not to use a range tree necessarily, but I think this problem is pretty cool because it admits a bunch of different solutions. So if you did solve this with a range tree initially, go back and do it with not a range tree, because that's interesting. I've forgotten how to clear. Okay, so the idea is this. It's actually a sweep line. So this problem is both a sweep line and a DP example. So you have your platforms. You can do it with a set. You can do it with a set. You can do it with a variety of structures, but I'm going to explain the sweep line solution with the thing. Yeah, so what you're going to do is you're going to sweep in this direction. And the idea is, it's relatively simple. Whenever you get to a new platform, all you need to do is to find the most recent platform here on this left end and the most recent platform here on this right end. So what you can do is you can build a range tree, and the range tree stores for each position the most recent platform that is over there. So for example, in this case, if we're considering this red platform here, the range tree would look something like zeros. There's zeros everywhere. And then if this were platform 1, then it'll be a bunch of 1s, and then it'll be zeros again. So this is like 1. And so when you drop down here, it's just a query of what value is at that position in the range tree. And so you know that if you were to drop down off of this platform at this end, you would get to 1. And if you drop off the platform at this end, you would get to 0. So you would fall off. And then once you've done that, now you add this range into the range tree. So in summary, your thing would look something like this now, if this were platform 2, after you add it. And so you can repeat this process with all the platforms as you go up. Each time it's just 2 queries of what platform is at this left and this right end, and then it's just a range set operation over the interval that platform covers if you sweep them in order from bottom to top. This is how you can solve this problem with a range tree. Now, if you choose to sweep in other directions, you can solve this problem without a range tree. For example, if you sweep from left to right or right to left, there's a different solution for that. And sweeping from top to bottom actually gives you a different solution as well. So that's all very interesting. Okay, so are there any questions about this particular problem? Sounds like there are no more questions. Okay, that's kind of all that I had to say about DP problems and range trees. So the thing about the thing about DP problems is that there's not really all that many tricks to show you with DPs and range trees. It's just about you recognizing the DP recurrence and trying to find one that makes sense. Oh, I mean, I guess that might be interesting. Okay, I just thought of another problem that I might want to show you that's pretty cool. So I'm not done actually. Okay. This problem might make no sense, but I guess we'll find out. Okay, so you have a nice chocolate bar, and the chocolate bar consists of n segments. Where is the... Yeah, it consists of n segments. Oh god. It consists of n segments. You would like to break the segment into two pieces. So let's say you break it here, and the amount of pleasure you derive from breaking it at a given point is given by a specified matrix. Rip stream. Is the stream dead? So I'm going to call it P. So Pij equals pleasure you get from breaking a piece into two segments, one of size I, the other of size J. This text is incredibly tiny. There we go. Oh, okay, there we go. Yeah, so let me reiterate the problem. Oh. Yeah. You're given a chocolate bar that consists of n segments. You want to break it somewhere so that you maximize your pleasure. And the pleasure you get is given by this function. It depends on the size of the two pieces that you broke it up into. And once you've broken up the segment into two segments, you can continue breaking those segments down further and further until eventually you get to lots of singular pieces. And you want to maximize the total pleasure that you get along the way from doing this. Okay, does the problem make sense? Okay, so the question that you might ask yourself is, dang, this seems pretty hard. What are the constraints on n? N squared. I mean, this matrix is like squared, so you can't really do much better than that. I don't think anyway. Yeah, so let's take a look at very quickly the naive solution. dpn equals the max for all I of dpi plus dpj. Plus p of ij. So you look at this and you're like, dang, that seems pretty hard to optimize. What can we do? Should j be n minus 1? Oh yeah, my bad. This should be n minus I. Yep, there we go. Now that's out of frame, but I can, yeah. Oh, you're right, it is already order n squared. I really haven't thought this problem through. Okay, let me rephrase the problem slightly. I mean, does that make sense if I rephrase it like that? Don't really feel like it does. Okay, I don't think this problem makes sense anymore. That's unfortunate. Alright, in that case, I don't have an interesting example to show you anymore. Yeah, I know, that's very sad. Okay. So I think the last thing that didn't actually end up getting through was more complex range tree operations. There was a cool JOI problem linked a while ago. It's basically like the classic. Maximum independent subsequence sum. There's some kind of discussion going on, but I don't really know what it's talking about. So I reckon I'm just going to move on to the section about more complex range tree operations. Does that sound good? Or is this something that you wanted to discuss, Kwang? Okay. Want to do purview. Oh, that's a good point. I should do a editorial for the AWO and the Fario. That's something I should do. Yeah, we normally do the what do we call them? I don't remember what we call them. But I forgot that that's something that we should do at camp. That we did at camp that we should do again. But I think that's something I'll do at a later time so I can do all the problems together. Debrief, exam debrief, that's right. Yeah, I'll get on to writing one of those or something. Okay, so more complex range tree operations. Can I just Control Z this away? You can. Okay. Yeah, so here's a problem. I give you an array and it has like a bunch of values. And I want you to find the size of the longest block of elements that are the same. So in this particular example, 5 occurs 4 times in a row. So the answer for this array would be 4. And you want to be able to answer this question for different subarrays. So for example, in this subarray, the answer would be 2 because 3 appears twice in a row. And you also want to be able to facilitate updates of the form, I change an element of the array to be another number. Does that make sense? Okay. Query, what is the length of the longest segment of elements that are all the same? Update, change an element. So what you do here is you kind of notice like, okay, if you think about the range tree, this is the range covered by one node, and this is the range covered by its 2 children. So typically with a max tree, what you would do is you would say the max of this node here is the max of my left child and my right child. And you kind of feel like you can do the same thing here. Like the longest segment of elements that are all the same for this node, this long node, is the length of the longest segment of elements that are same in the left side versus the longest segment of elements that are all the same in the right side. So the longest set of elements in the row on this side was 4, there were 4 elements, and this side was 3. Then the value for this entire range should be 4. Now, that works, except you run into problems when the longest segment kind of straddles the gap between these two, between the two children. So for example, if your array was something like, I don't know, 1, 2, 3, 6, and on this side it's like 10, 11, and so on, and the gap is like here between these two, then the length of the longest segment on the left is 5. The length of the longest segment on the right is, actually let's do a different example. So it's like 6, 6, and then like 3, 3, 3, 3, 3, 3, 4, 4. Yeah, and the length of the longest on this side is, oh geez, is also 5, but when combined together, there's actually a string of 7 consecutive 6s. So because this particular segment straddles the line between the left child and the right child, it kind of gets missed. So when you want to do like m equals max of left child's m and right child's m, then it doesn't quite work because of this case specifically. So what you can kind of do is you can kind of monkey patch this in by keeping for your left child tracking the length of the longest suffix and what number it is. So for this particular example, you know that the longest suffix is, the length is, it's maybe let's say it's 5 consecutive 6s. And for this side over here, we're looking at the prefix because we want to look at the join in the middle. It's 2 consecutive 6s. So in order to combine them, you also have to check if left suffix number equals right suffix number, right prefix number I mean. Yes, this is pretty much the same idea as Ms. Nazem, as the maximum non-adjacent subarray sum problem. Subsequent sum, I mean. Chikingi is typing. Several people are typing. Indeed. So yeah, if the left suffix number is equal to the right suffix number, then you need to do the check. It's like, oh gosh, m equals, can I move these things? Maybe with this? Wonderful. Equals max of m and left suffix size plus right suffix size. Okay. So does that make sense to everyone? So if you keep track of for your left child, it's the size of its largest consecutive suffix, and for your right child, you keep track of the size of its largest consecutive prefix. Then you can use that to figure out what the size of the range straddling these elements is. So the one problem is that because each node in the range tree is kind of like a homogeneous cog in the machine of the range tree, they all kind of have to be identical, because you know this node here, this large node, is potentially a child of another node itself. And so if that's the case, for the parent node to know what its maximum longest length is, it also needs to be able to keep track of the suffixes and prefixes. So in addition to calculating m, which is the value that we're interested in, we also need to keep track of the left side and right side suffixes, prefixes and suffixes. So in addition to this, you would have something like left suffix num equals left child. Wait. No, yeah, suffix num equals right child's suffix num, and suffix length is equal to right child's suffix length. So basically what you're saying here is my right child suffix is going to be my suffix as well. So I'm just going to copy those values over. And similarly, it's pretty much the same for the prefix as well. Your prefix is going to be your left child's prefix. So you need to copy that over too. So if you keep track of all of those values throughout every node of your range tree, you should be able to facilitate these operations. Do you mean the max of right prefix size? Which line am I looking at? I have lines everywhere, and now I'm confused. Max of right prefix. So my right's prefix size. So like this. This section here. Oh, right, I see. Yes, this should be prefix. My bad. Thanks for catching that. So yeah, if you use this, if you keep track of all these values, you can now answer queries and updates of this form. So one thing that you might want to be able to do is, instead of change an element, you might want to do something like set range. And conceptually, the problem is kind of still the same. The only thing that really changes is that now you have to implement lazy update. So at least from my perspective, the way that I tend to approach these kinds of problems is I look at, even if I'm required to implement a range update of some form, I look at the point update version first, because you need to be able to solve that anyway to be able to solve the range update. And more often than not, the ideas are pretty much the same, except you have to do some extra plumbing to get the range updating things to work correctly. Okay, are there any other questions about this problem? Okay, cool. So there isn't technically a problem that you can practice on Orac, but there is. It's this one, vitamin D. I don't think I want to go through it here, but you can actually kind of turn vitamin D into pretty much this problem I described here, using some clever things. You can of course do it the normal way with a range tree in the obvious kind of direction. But if you want to try to figure out how to transform the problem into this one as well, that's also a very interesting exercise. And if you're super motivated, you can actually solve vitamin D in linear time without a range tree. So that's like a stretch goal if you want to attempt that. Okay, cool. I think that's all of the content that I had planned to cover in terms of basic range trees and things. I had a quick look through the responses for other things that people wanted to cover, but they're all like kind of advanced things, and it's not something I wanted to get into at the moment. And it's also the kind of thing that I would probably have to prepare more than I did for this, which I didn't prepare for at all. And now that I think about it, I probably should have. But yeah. So I guess if there are no further questions, do people have feedback on how this was actually run? So this ended up going for like something like 3 hours, and I guess it was okay, but do you have any suggestions or improvements? It was very nice. I thought it was nice too. Yeah, the latency was a lot lower than I expected. I'm kind of impressed that, my opinions are my own, not that of Google's, that the latency is so low. I can actually show you this. There's like 3 options for stream latency. There's like normal latency, low latency, and ultra low latency. So this is as fast as it gets. Maybe Discord would be good for next time. Yeah, if that's something that works consistently for people and the latency is a lot lower, then I'd be happy to try that. Although I'd have to figure out how to set up recording with OBS, because I don't think Discord does an automatic thing for you. Yeah, if it's something that I actually like being voice chat. Oh, that's a good point. What if we all just joined voice chat or something? Like, it doesn't even matter where the live stream is. Like, couldn't we all just be in voice and people ask questions if they want? Do you want to try all that now? Get into the chat. Oh,
Do you want to try?
my ears.
Hello. Yes. I guess we're just gonna have to mute the thingamajig.
What thing?
Um.
Yeah, I definitely feel like I can hear my own voice echoing through your mic.
Yes, because I have my volume turned down.
Okay. So I guess in the future, we could just have everyone in the voice chat, and if people wanted to pipe in with questions, that might be a lot more natural than people typing things into the chat and then hoping that I see it eventually. Oh, is it looping? Oh no. Is the stream sound looping?
Oh, is it looping? Oh, no. I mean, the stream doesn't need to transmit audio anymore.
Why is it looping? Well, I mean, the problem is that if we don't have the stream audio, then the recording is going to be kind of not that great, right?
Kwong, you're very loud.
You can adjust the volume of different people. Just right-click on their name. For some reason, I have Tune On set up to max. I have set you up.
Kwang is significantly louder than you, Kevin. Okay.
I mean, you can just do it to taste.
Is that because I'm too quiet? What if I move the mic closer? Is this better?
Oh my god, yeah.
Can you hear me better?
That is, yes, we can hear you better.
Okay. I wish someone had said something, because that's a minor change.
I mean, I just turned up my volume. There was nothing wrong with that.
So the way that my workstation is set up is that I don't actually have a microphone stand. So I've got like this tiny desk microphone, except like it's really short. So what I ended up doing is I just tuck my desk microphone into the collar of my shirt.
Oh.
And if I'm wearing like a shirt with like a really low kind of collar, then I'm a lot softer than I normally am.
Oh. Interesting that you actually have like a good microphone.
Oh, thanks. It costs like $25. It's really cheap.
Ah.
Okay, so I guess in the future we can try doing something like this. The looping is due to...
Can you just draw a line on the
Does anyone?
Can you just try to draw a line on a whiteboard and see what happens? Because kind of doesn't make sense when you're like trying to point to something and then like you point to it on the screen like 2 seconds later.
Oh,
That's the problem, right?
oh,
So, like,
because
point
the
to something
voice
and
latency is
expect
going
you're
to
pointing
be
it.
low.
Sorry.
I mean, there's also like Google Meet, which is like incredibly low latency and also that's streaming. But I guess, yeah.
We're just like finding the lowest latency stuff.
What's it called?
Yeah.
It's called Hangouts Meet now.
Hangouts, right? Okay, maybe it
Google
would
changing
be
their
a better idea to use something other than YouTube. Because you're right, probably live streaming is more about having many concurrent viewers than it is about incredibly low latency. And from what I
Yeah.
remember, you can record Hangouts things.
I mean, you can just record your screen at the same time.
Yeah, so like essentially what I did when I streamed my like Codeforce editorial, I had a Discord stream going and I also had OBS recording my browser. So there were two things going at once and it worked perfectly.
I don't think I understand the setup, but I think that's something we can discuss later. But all right, it sounds like YouTube is not the platform that we need right now.
My views reflect that on my own and not of Google's.
How far behind are you in the lecture?
What do you mean? How far am I behind?
Like, that was like, he said that 10 minutes ago.
What did I say 10 minutes ago?
My opinions. Oh, I'm looping.
What is happening?
So confused.
Why are you
I
guys?
really don't understand where this source of looping is coming from. But it sounds like what the plan is now is for me to figure out how on earth Hangouts works. I actually use it every day for work, so that's kind of embarrassing. But I'll have to figure that out, and then we'll probably move to that, and I'll try to make sure that I can set up OBS to record it correctly, and then upload that to YouTube or something. All right, sounds like a plan.
Yo,
I have to turn off my microphone on Discord. But the problem with
Sorry?
that then is that the latency for the stream is going to be a few seconds behind.
Yeah, so just turn off the YouTube volume if you're in the voice chat.
But that means that if I'm speaking, then what's happening on the screen is going to be a few seconds behind.
That's what you get for like it's like
Oh, you're
Yeah, it's
saying
what you
that
get.
I should mute one or the other depending on which one I care more about?
yes.
Actually, I guess the alternative is that I should just mute myself
we need to find a
in
different
Discord
platform.
entirely.
That's why we were chatting. We weren't just in the voice chat because I knew that it's really disorientating. Like saying you're pointing to something and then like 2 seconds later you point to it.
God. Yeah, okay, I see what you mean.
So
Why is
that's why I'm.
technology so confusing.
Discord streaming worked fine, right? But once again, Max can't use it, so.
Yep, okay. I will find alternative arrangements and see if I can get things to work better. But yeah, thanks everyone for joining the inaugural online April Camp lecture. Hopefully you'll be seeing more of myself and other tutors as well doing these lecture type things. I would also like to find other things that we can do in like a social environment other than just me talking about or other tutors talking about stuff. Like it would be really cool if we could get together something like, you know, the visualization session or something like that over the internet as well. So stay posted. Thanks everyone. Any final questions, comments or remarks?
Yes.
Go ahead.
How do I contribute problems?
That's something that I am thinking about right now. But
Alright. J
can
King and
discuss
I
this
can
later.
make a very mean team.
yeah, do you like making problems?
I've got this streamline going, a pipeline.
Okay, it sounds
In-
like there are many
you
people.
put the problem in, and then you put and the test data pops out the other side.
Yeah.
Kevin, did you see have you looked at the ACIO contest we're running this weekend?
I have not looked at that actually.
Do you want me to zip? Like I was working until like 2 a.m. last night with like Tunan and Max working on like the best
Hi.
problem. By the way, Max, if you're saying something, I can't hear you. Wait.
No, I heard him.
Oh wait, what? Never mind. I'm just too loud for my own good.
I didn't hear Max at all. But maybe
said
I wasn't
hi.
paying attention. Oh, he just said hi. Hi, Max.
Hello, can you hear me now?
I can hear you.
Yeah.
Yes.
Yeah, I think lot
Oh,
of the
Kevin, if you want, I can register you.
Sure.
I think
Wait,
like,
what?
yeah, it's me, Junhua. Yeah, I think lots of the betas can like help set problems.
Okay,
Yeah,
now it's really looping.
We have some
Let me turn off
experience
the
in this.
stream so that this looping thing doesn't happen. Why are we even still watching the stream? There's nothing going on there anymore.